Los Peñasquitos Creek watershed has a land area of approximately 100 square miles, which include portions of the cities of San Diego, Poway, and Del Mar. The watershed is highly urbanized with a population of about 400,000 residents. The watershed flows into the 0.6 square mile lagoon known as Peñasquitos Lagoon. Our project begins with the urban runoff from the watershed flowing into the Peñasquitos Creek and then further flowing downstream until it reaches our diversion structure, at which point the flow is diverted from the stream and piped into pump station number 64. Upon reaching pump station number 64, our part of the project concludes, but it's part of a bigger scheme where the water will continue on to the North City Water Reclamation Plant, where it will be treated and used as irrigation water. Eventually, the water will end up being sent to the Advanced Water Treatment Plant and then flow into an environmental buffer where it will reside until being sent to the water treatment plant down the line and be used as indirect potable reused water.
This project is based out of the lower section of the Los Peñasquitos Creek, which receives stormwater flows that include rainfall and runoff from the entire Los Peñasquitos watershed, and runs parallel to the Interstate 5, starting in Sorrento Valley and flowing up into Torrey Pines State Reserve. The proposed project site is located downstream of the railroad track overpass, where the creek and the storm drain canal meets. The ground elevation of the project site location is approximately 24 feet mean sea level, and the ground level elevation increases to a maximum of 40 feet mean sea level along the proposed pipe path. According to the previous geotechnical studies and lab research conducted by Nino and Moore, soils discovered in the area of the project site were discovered at depths between 20 to 105 feet and include fill, colluvium, alluvium, Torrey sandstone, Ardeth shale. Groundwater was also discovered at approximately 6 to 21 feet below ground level. Liquefaction is likely to occur in saturated or near saturated cohesion, less soils at depths shallower than 50 feet below ground surface. Based on the relatively loose nature of the alluvial soil, the potential of liquefaction is very high. Based on studies of the reference geological maps and aerial photographs, the project site is not underlain or across any known active or potentially active faults. However, the site is located in a seismically active area, as are the majority of Southern California, and the potential for strong motion is highly considered for the life of the structure to be designed. In conclusion, to the geotechnical study, construction of the proposed project is feasible from the geotechnical standpoint. However, the anticipated groundwater levels may be a constraint during excavation, causing difficulty conditions for heavy equipment.
We calculated our incoming flow using the nearest USGS monitoring station located in Poway. Our proposed harvest site is located a few miles west of that area, so in order to get an accurate representation, we needed to consider about 7 miles worth of additional commercial and residential flows. From the USGS monitoring site, we found an average initial flow of 1.56 CFS. We used this as our minimum flow in our evaluation. Then we used urban dry weather runoff generation models from the Los Angeles Integrated Resources Program to calculate an additional flow of 6.33 CFS. In light of this, dry water engineering has decided to be conservative in our approach to minimize disruption to the existing environment and settled with a target recovery flow of 1.5 CFS for our project. Typical sources of urban dry weather runoff include irrigation, car washing, road and pavement washing, leaky water mains and fire hydrants, and industrial outflows from factories, all of which enter into the storm drain and discharge into receiving water bodies, in this case, Los Peñasquitos Creek. Naturally, this runoff comes with a list of contaminants, including nutrients, sediments, organics, metals, litter and debris, pesticides and herbicides from irrigation, oil, grease, and other hydrocarbons from streets, and various forms of bacteria and viruses. For the purpose of this project, dry water engineering has made the assumption that our target recovery flow and corresponding contaminant concentration complies with levels the North City Water Reclamation Plant is capable of handling.
It was determined that the proposed project will have a greater impact on the Peñasquitos Lagoon downstream. This will reduce the flow of fresh water as well as sediments and nutrients which the lagoon is known to have problems with. The reduction of fresh water and sediment will restore the lagoon back to the salt marsh it used to be. This will benefit native species and will hinder invasive species which have been a problem in the lagoon. Many of the native species are currently endangered. The proposed project will also slow down the degradation of the lagoon. There are some risks that come with the location of the diversion. Since the location has a high chance of flooding, the diversion placement is subject to change. Mitigation will be addressed to account for 4 cubic feet for every 1 cubic foot of land disturbed. During the design step, we wanted to make a simple diversion with a low cost and be natural looking to fit the creek. With this criteria, we determined that a Gavion design for the diversion would be most effective. The Gavion design will reduce the water flow enough for the water to be collected. The water will be collected with a perforated pipe which will be located within the Gavion. The Gavion itself will work as a natural filter to remove large particulate from the water. A PVC liner will be used to reduce the flow of the water through the diversion.
Once the flow has been diverted, it will enter a pipe we have placed that will travel a short distance to an existing sewer line. The red line represents our proposed pipe, which hooks into a green line that is an existing sewer pipe. At the turn in our pipe, a cleanout will be constructed to provide an access point for maintenance in addition to a valve. Within the cleanout, sensors including rain and combustible gas will be housed to ensure that in the event of an emergency spill or rain event, the system can be shut off. The water will then flow through the existing sewer line until it reaches pump station number 64, approximately half a mile away from the diversion.
The estimate of this project is above $1 million. The estimated construction duration is about 5 to 6 months. The duration is based on the construction schedule from mobilizations and to material delivery, and after the equipment is set up during the earthwork. During the earthwork duration, the embankment can be installed, and every 10 feet of the, 10 to 20 feet of the excavation is done. The pipeline can be set up and until the finishes of the project. There's a maintenance fee of $1,500 per year to do the clean of the embankment because it's a natural filter. Here is the breakdown of the total price of the project. We can see that it include construction cost, environmental cost, and RFI permitting cost.
In conclusion, I would like to reference the San Diego Long Range Water Resources Plan, which illustrates new possible sources of water capture. Decentralized stormwater capture is the only one of those options that is on the same scale as our project, but it has a cost of $19,000 per acre foot. Our project, however, provides a source of revenue. We plan on harvesting 1,000 acre feet of water a year, which has a going price of $1,100 per acre foot, which can give us $1 million of revenue in 1 year. Our cost is about $1 million to build the project, so it has paid for itself in 1 year, and every year after that will be providing the city revenue. This project not only serves to provide a solution to a complex regulatory issue, but it also provides San Diego with a new water source, and it provides the city of San Diego with a new source of revenue. We here at Dry Water Engineering would like to thank you for listening to our presentation on the dry weather urban runoff water harvesting of the Los Peñasquitos Creek. And as for the team at Dry Water Engineering, where the water stays wet and the humor stays dry, we have Andrew Donovan serving as the project manager in charge of hydraulics. Next we have Kenneth Santos, who's working on construction estimation is none other than Ronnie Zoo himself.